Alright guys, now in this module, we'll start circles, a very small and very easy chapter. Now before we talk about this year what you have in circles, we'll just quickly recap what you learned last year because we'll need some of those things to solve problems. So what do we know? From last year, what we know is angle made by a chord, or basically it means from the same 2 points. If it is making angle with center and circle from the same 2 points, this angle will be double of this angle. So if this is x, this will be 2x. When angle is made in the same segment, if you remember. Now angles made by the same chord on the circle are equal. So if this is x, this also will be x. From the same 2 points, if I draw like this also will be x. So any angle made on the circle from the same 2 points or the same arc is, or the same chord, you can call it, it is like a chord, right? If you join this, so this angle will be equal to this, and all these angles will be half of the angle made to the center, subtended at the center. Now second thing that you need to remember, if this is diameter always makes angle of 90 degrees with the circle. Anywhere on the circle it will make 90 degrees. So from diameter, if it is making here, this also will be 90 degrees. So diameter always makes 90 degree angle with the circle. You need to remember this. And one more thing that you need to remember is, this is angle made in the same segment. What about angles made in the opposite segment? For example, this. Now this is subtended at the center from the same 2 points you have in the opposite segment. So this will be half of reflex angle, or you can say reflex angle is double of the angle made in the opposite segment. So these three important things you need to know for this year. Before to solve, you might get problems where you'll have to use these kind of basics. Alright guys, now coming to this year, what you need to know. There are only two things you need to know. A tangent will always touch a circle at one point, and the line from center to the tangent always makes 90 degree. You can draw any tangent anywhere you want. Okay, it just touches the circle at one point, and line from center to the tangent will always make 90 degree. This is the first thing you need to remember, that a line from center of the circle to the tangent will always make 90 degree. The second thing you need to remember is, from an external point, you can always draw only two tangents to a circle. So from any external point, you can only draw two tangents to a circle. And remember, this side will be equal to this side. That is from this point to this point, and this point to this point. So from the point where tangent is touching the circle to the external point, and from here also from the point where it's touching the circle to the external point. So this side will be equal to this side. This is the second thing you need to remember. Now one more thing you need to remember to solve few problems are, see, this forms a quadrilateral, right? Four-sided figure. So this is a quadrilateral. This is 90 degree, this is 90 degree, totally 180 degree, which means how much will be this angle plus this angle? A quadrilateral angle sum property of a quadrilateral is 360. The sum of all angles will be 360 degree. Hence, since these two combine to give 180 degree, this angle plus this angle will be 180. So for example, if this is 60 degrees, this angle will be 120 degrees. If you say this angle is 100 degrees, it means this is 80 degrees. So these are the things that you need to remember to solve any problem in circles. And now we'll start with your answer solutions. I'm not going to explain exercise 10.1 because it's very easy. You should be able to do it. We'll be explaining exercise 10.2 in this module. Alright guys, the first question from exercise 10.2, they have said length of from a point on the circle to an external point Q, the length of the tangent is 24 centimeters. So this is the tangent, and they have said the distance from Q to center of the circle is 25 centimeters, and we have to find the radius. Now how do we do this? We know line from center to tangent always makes 90 degree. So this is a right angle triangle. So we know two sides. Using Pythagoras theorem, we can find the third side. So what is hypotenuse? Hypotenuse is 25. So hypotenuse square equal to radius. This is radius, right? Radius square plus 24 square. Now 25 square is 625. 24 square is 24 into 24. I think it's 576, but just to verify, 8 2 6, 8 plus 9 7 1. Oh, sorry, this is for 5. So yeah, it is 576 equal to r square plus 576. Now I'll transpose 576 this side. I get 625 minus 576 equal to r square. Now 625 minus 576 is this becomes 15, this becomes 11, this becomes 5. 15 minus 6, 9, 11 minus 7, 4. So I get 49 equal to r square. Therefore r equal to root of 49. So r equal to 7 centimeter. So the radius of the circle is 7 centimeter. Alright guys, the second question, they have given you this figure and they have given you this angle and they have asked you to find angle PTQ. Now this is the external point, these are the two tangents. Line from center will make 90 degrees. Like I explained previously in the module, this plus this is 180, which means this plus this has to be 180. Why? Because this is a quadrilateral. So 180 is taken up by this. How much is remaining? 180. So this angle and this angle are supplementary. Since this is 110, this will be 180 minus 110. So it will be 70 degrees. Answer is 70 degrees. Alright guys, now the third question they have given you is PA and PB are external tangents from an external point P and they are inclined to each other at 80 degree, which means this whole angle is 80 degree. They have asked you to find angle POA, which is only this much. Very simple. Now the thing is, like I told you, the way you prove this side is equal to this side is by proving congruency of these two triangles. This triangle PAO and PBO will be congruent, which means this angle will also be equal to this angle. Now this entire angle is 80. How much will this whole angle be? 180 minus 80, because these two are supplementary, right? If you remember, this plus this should give you 180. So this whole angle will be 180 minus 80, that is 100 degrees. So angle AOB equal to 100 degrees. Now since this is equal to this angle will be half of the entire angle. So angle POA will be half of 100, right? Which is equal to 50 degrees. Alright guys, now the fourth question tells you prove that tangents at the end of a diameter. So tangents created at the end of a diameter are parallel to each other. So you have to prove this line is parallel to this line. So I have drawn this figure. Let the diameter be AB, center is O, and let this point be D and let this point be C. Now what do we have? We have a line from center to the circle. Line from center of the circle to the tangent makes 90 degrees. So we have angle OBC equal to 90 degree. Similarly, angle DAO is also 90 degree, right? So DAO is also equal to 90 degree. What is the reason? Because line from center to tangent. So this is the reason you will write. Alright. Similarly for this also it's the same reason. Now since this is the diameter, this is a straight line, which means it is intercepting these two lines. Right? This is a straight line which is intercepting these two lines. And what do we have? The sum of angles on the same side, that is OBC plus DAO is equal to 180 degrees, 90 plus 90. So since sum of internal angles on the same side is 180, you can say AD is parallel to BC. What is the reason? Sum of internal angles is 180 degree. So if you remember, how do you check whether a line is parallel? This angle plus this angle should be 180 degree, and we have this as 90, this as 90. So this plus this is 180. Hence this line is parallel to this line. Now the sixth problem says that the length of a tangent from point A to the circle, from point A, which is 5 cm away from center of the circle. So A is 5 cm away from center of the circle and the length of tangent is 4 cm. They have asked us to find the radius. Again very simple, this is 90 degree, this is a right angle triangle. So using Pythagoras theorem, hypotenuse square 5 square equal to r square plus 4 square, right? So 25, 4 square is 16. When I get it this side, it becomes minus 16 equal to r square. So we get 9 equal to r square. So r equal to root of 9, that is 3 centimeters. So the radius is 3 centimeters. The seventh question, guys, they have said there are two concentric circles, which means one circle inside the other with the same center. The smaller circle radius is 3 centimeters. So this is 3 centimeter and the larger radius is 5 centimeter. They have asked you to find the length of the chord which just touches the smaller circle, which means it will be tangent to this circle. So we have, this is radius of smaller circle, this makes 90 degree, this is radius of bigger circle which is 5 centimeters. We have a right angle triangle. So we can find this point. Let this be A, let this be B. So AB square, this square plus 3 square equal to hypotenuse square, right? So AB square equal to 5 square is 25, 3 square is 9. When I take 9 that side, it becomes minus 9. So AB square equal to 16. So AB equal to 4 root of 16, that is 4 centimeter. Now we got this as 4 centimeter. Now if you remember from last year, this is a line from center perpendicular to the chord, which means it will bisect the chord. So this side will be equal to this side. This is another thing that you have to remember from 9th standard. So since this line is perpendicular to the chord, from center it bisects the chord, which means this also will be 4 centimeters, which means length of the chord will be equal to 4 plus 4, that is 8 centimeters. Now the next question, they have said a quadrilateral ABCD circumscribes a circle, which means these points are touching, these points on the circle are touching the quadrilateral, and they have asked you to prove that AB plus CD equal to AD plus BC. So this plus this equal to this plus this. Very simple problem, guys. Now this is like a tangent to the circle because it will touch only at one point, which means what do we have? AS equal to AP. We have PB equal to QB. Why? Because this is an external point and two tangents are being formed. Similarly, this side will be equal to this side and this side will be equal to this side. So what do we get? AP equal to AS and PB equal to QB. PB equal to QB. Also we have RC or CR. CR equal to CQ. This equal to this, and we have DR equal to DS. Now guys, AB plus CD. AB plus CD is equal to, now AB plus CD is what? AP plus PB, right? AP plus PB plus CD. CD is CR plus DR. So CR plus DR. But what do we have? AP equal to AS plus PB equal to QB plus CR is equal to CQ plus DR equal to DS. So we can write it like this also. Now if you observe, AS plus DS is equal to, okay, I'll rearrange. AS plus, I can write this as AS plus DS plus QB plus CQ, right? Now AS plus DS is AD plus QB plus CQ. QB plus CQ is BC. Hence AB plus CD equal to AD plus BC. The next question, guys, they have said xy and x dash y dash are two parallel tangents. Now parallel tangents, and this is line from center joining, so this will be 90 degree, this will be 90 degree, right? To a circle, and AB is also a tangent touching at point C, and they have asked you to prove that AOB, this angle is 90 degrees. Now they have said this is point C touching. I'll draw a line from center to C. Now if you see these two triangles, from triangle APO and AOC, triangle AOC, what do we have? These two triangles will be congruent. Why? This is like a tangent point, external point, and these two are tangents to the circle, which means this and this these two triangles will be congruent. So what do we have? This angle, that is POA, angle POA equal to angle COA, equal to angle COA, because these two are congruent. Similarly, again, this is like an external point. From an external point, two tangents are drawn, which means these two triangles also will be congruent. So what do we have? From triangle COB and triangle QOB. What do we have? QOC, angle QOB will be equal to angle COB. Now this is a straight line. POQ is a straight line. Why? Because they have said these two are parallel and this are 90 degrees. This will be a straight line. Basically, this is the diameter. So that is how we get these two 90 degrees. Since this is the diameter, angle POQ will be equal to 180 degrees, right? This entire angle is 180 degrees, which means POA plus angle COA plus angle QOB plus angle COB will be equal to 180 degrees. But what is POA and COA are equal, which means I can write it as 2 times COA plus similarly this QOB and COQ are equal, which means I can write it as 2 times COB equal to 180 degrees. What is common in these two? 2 is common. I can take 2 common, right? So I get COA plus COB, 2 into this equal to 180. When I transpose this to that side, it becomes by 2, which is equal to 90 degree. So now we have angle COA plus COB equal to 90 degree. But what is angle COA plus COA plus COB? This angle plus this angle is angle AOB, which is equal to 90 degrees. Alright guys, now the next question they have said, prove that angle between tangents drawn from a point P, let's say the point P, is supplementary to angle subtended at the center by points of contact to center. So basically what I've already told you, they have asked you to prove that this and this are supplementary angles, which means this plus this should be 180 degree. Very easy. Now line from center to tangent will make 90 degree, 90 degree. What do we have? We have angle A, okay, we'll make it better. Angle PAO plus angle AOB plus angle OBP or PBO, whatever you can write it as, plus angle APB is equal to 360 degrees. Why? Angle sum property of triangle. You can write of quadrilateral, angle sum property of quadrilateral, right? My handwriting has gone for a toss, but I hope you can understand. See, this is a 4-sided figure, right? 4-sided figure. So it's a quadrilateral. What is angle sum property of quadrilateral? Sum of all 4 angles will always be 360 degree. So we have this angle plus this angle plus this angle plus this angle. But what do we have? Angle PAO. PAO is 90 degree, right? Because line from center touching the tangent. Similarly, okay, we have AOB here plus PBO. Angle PBO is also 90 degree plus angle APB equal to 360 degree, right? So now we have 90 plus 90, 180 degree plus angle AOB plus angle APB equal to 360 degree. Now when I transpose, what do I get? AOB plus APB equal to 360 minus 180 degree, which is equal to 180 degree. Therefore, AOB and APB are supplementary. Sum of the two angles will be 180 degrees. Alright guys, now the next question, they have said prove that a circle inscribed in a parallelogram is a rhombus, or a rhombus circumscribing a circle is a parallelogram circumscribing a circle is rhombus. Now they have already said this is parallelogram, which means what? We have AB equal to DC and we have AD equal to BC. Opposite sides of parallelogram are equal. How do we prove it's a rhombus? All four sides should be equal, which means if we show this and this side are equal, or this and this side are equal, or this and this side are equal, any of the two adjacent sides are equal, we'll get all four sides are equal. Alright, now see again, this is like an external point, this is tangent, this is tangent. So this side will be equal to this side, this equal to this, this equal to this, and we have this equal to this. Now guys, AP plus PB, AP plus PB plus DR plus CR, DR plus CR will be equal to this plus this plus this plus this. This is equal to this, this is equal to this, this is equal to this, and this is equal to this. Hence AP plus PB will be equal to AS plus QB plus DR plus CR will be equal to DS, DR will be equal to DS plus CR will be equal to CQ. Now AP plus PB is AB plus DR plus CR is DC, right? AB and DC equal to AS plus DS. AS plus DS is equal to AD and QB plus CQ equal to BC. So we get AB plus DC equal to AD plus BC. But since this is a parallelogram, AB plus DC is equal to AB, which means I can write this as 2AB equal to, similarly AD is equal to BC since it's a parallelogram. So I can write this as 2AD. So what do we get? 2 and 2 cancels, we get AB equal to AD. So we have proved adjacent sides are also equal. Therefore, AB equal to AD equal to DC equal to BC. Therefore, ABCD is a rhombus. Alright guys, the 12th question, they have said triangle ABC circumscribes a circle, which means the circle is inside the triangle and it touches the triangle at 3 points. They have said radius of the circle is 4 centimeters. They have given you these two sides and they have asked you to find AB and AC. Now guys, like this is an external point, so this side should be equal to this side. So I'll mark it as P and Q. So which means DB is equal to PB, which means this is also 8 centimeter, and similarly CD will be equal to CQ, again tangents from external point. So this also will be 6 centimeter. Now let this be x and x. This the length of AQ, let it be x, which means AP also will be x. Why? Because again external point and two tangents from external point. So now we have only one unknown. To find AC and AB, we only need to know the value of x. To find one unknown, we need one equation. Guys, generally there is one more kind of problem that you get. In that problem, generally the easier problems will be where they give you area of triangle. Generally they will give you area of triangle and you have to use formula for area of triangle and find the value of x. In this, they have not given you the area of triangle, which means a triangle has two formulas to find the area. One is half into base into height and other is Heron's formula, that root of s into s minus a, that formula. So here we have to equate the first formula to second formula, because area of the triangle, whether you use half into base into height or whether you use Heron's formula, the area will be same. Now the trick is we'll divide this into 3 different triangles. Okay, so the triangle is, the 3 triangles are COB, BOA and AOC. So these are the 3 triangles that we have. What will be area of triangle ACB? Total area of triangle ACB will be area of triangle COB. So what is area of, now this is line from center to tangent, this will be 90 degrees. If we draw here, this also will be 90 degrees. If we draw here, this also will be 90 degrees. This is 4 centimeter, this is 4 centimeter. Why? Because it is radius, right? This line is also radius, this line is also radius. Now since this is 90 degree, this is the height for this triangle. So what will be the area of triangle COB? Half into base. Base is CB or BC, which is 6 plus 8, 14. Half into base into height is 4, right? Plus, now we will take this triangle area. This triangle. What is it? Again half into base is what? 8 plus x. This thing is the base. So you get base as 8 plus x into height. Height is again 4 plus. Now if we take this triangle, again half into base into height. So half into base. Base is this. This is 6 plus x into height is 4. It's making 90 degrees, right? Hence it is the height of the triangle. This will be equal. This area of this triangle plus this triangle plus this triangle is area of triangle ABC. Now using Heron's formula, what do we get? Heron's formula is root of S. But what is S? Sum of three sides. So this is 6 plus 8, 14 plus 8 plus x plus 6 plus x by 3, right? This is the, oh no, sorry, this is by 2. So this is how we find value of S. Sum of three sides by 2. So we have 14 plus 8, sorry, 14 plus 6, 20, 20 plus 8, 28 plus 2x by 2. Now I can take 2 common here. So I get 2 into 14 plus x by 2. So 2 and 2 cancels, which means S is how much? 14 plus x. So if you remember Heron's formula, root of S into S minus A into S minus B into S minus C. This is Heron's formula. So S is 14 plus x into S minus A, that is 14 plus x minus one side, that is, let's say this side we get minus 14 plus S minus B, 14 plus x minus this side. So I'll put bracket 8 plus x. So S minus this side plus 14 plus x, that is S, minus C, that is x plus 6. The value of the third side is x plus 6. So we have applied this formula. Now if you see here, I can take 1 by 2 and 4 common. So I get 1 by 2 into 4 common. Here what do I get? 14 plus 8 plus x plus 6 plus x. Because I have taken 1 by 2 and 4 common. Equal to, now here what do I get? Root of 14 plus x remains like that. Plus 14 minus 14 cancels. So into x into, now when I open this bracket it becomes minus 8 minus x. So minus x plus x cancels. 14 minus 8 is 6. Again when I open this bracket, this becomes minus, this becomes minus. Plus x minus x cancels. I get 14 minus 6, that is 8. So I have got this much value over here. Now simplifying, 2 ones are 2s are. So I get 2 into 14 plus 6 plus 8, 28 plus 2x equal to root of 14 plus x into 6 8s are 48 into x. So this is what we have got till now. So now if I can remove the square root. How? I have to square on both sides. If I square on both sides, I can remove the square root. Or rather wait, I can take 2 common from here again. So it will become 2 into 2, 4, and this becomes 14 plus x. And when okay, this will remain like this, 14 plus x into 48x. Now squaring both sides, here it becomes 4 into 14 plus x whole square equal to root of 14 plus x into 48x. Remember, if I am doing any operation, I have to do it on both sides. So this square and square root cancels. Here I get 4 into 14 plus x whole square, which is 4 square, that is 16 into 14 plus x square from here, equal to I get 14 plus x into 14 plus x into 48x, right? From this side, I'll just erase this. Now 1 14 plus x and 1 14 plus x will cancel. Why? Because here it is this into this. When I transpose on the other side, it goes down. Or okay, I'll do it step by step itself, like our name. So now I'll transpose this 14 plus x. I get 16 into 14 plus x whole square by 14 plus x equal to 48x. Now 14 plus x and 1 14 plus x cancels. Again this 16 I can transpose on the other side. So it becomes by 16. 16 ones are 16 threes are. So what do I get? Remaining here 14 plus x equal to 3x. Now transposing x on the other side, I get 14 equal to 3x minus x right? When I transpose this plus x, so I get 14 equal to 2x, right? So x equal to 14 by 2, which is 7 centimeter. Now I got the value of x as 7 centimeter. So now what will be AB? We don't have place, I'll write it here. AB will be equal to 8 plus 7, which is 15 centimeter, and AC will be equal to 6 plus 7, which is 13 centimeter. Alright guys, now this is the toughest problem they can give you in circles. It's a very easy chapter. If you get a problem like this, remember, if they give you the area, you have to just use this, divide it into 3 triangles. So sum of area of the 3 triangles will be equal to the given area of the whole triangle. But if they do not give you the area, just remember, you have to use the 2 different formulas for areas of triangles. You have to first split 3 triangles, use half into base into height, and that will be equal to the area of the whole triangle where you are using Heron's formula. So all the basic calculations, I am pretty sure you will be able to do. Alright guys, now the last question in the exercise, they have asked you to prove that opposite sides of a quadrilateral subtend supplementary angles at the center, which means these two opposite sides, this angle plus this angle is 180 and this angle plus this angle is 180. That is what you have to prove. Now how do we prove? Very easy. One sec, I'll just fix this. Alright. Now let PQRS be the points where quadrilateral is touching the circle, which means this is an external point, this is a and the 2 tangents from external point, which means what? This triangle POB equal to triangle QOB. Alright guys, similarly we have this triangle congruent to this triangle and this triangle are also congruent. So we have triangle OSA congruent to triangle AOP, which means we have from this triangle we have this angle equal to this angle, right? So QOB, angle QOB will be equal to angle POB. Similarly, we'll have angle POA equal to angle SOA. Now just like this, here also it will be the same case. This angle will be equal to this angle will be equal to this angle, right? Because these 2 triangles are congruent, So similarly, we will get angle QOC equal to angle ROC, and we'll get angle ROD equal to angle SOD. But now what do we have? Angle AOP plus angle POB plus angle BOQ plus angle QOC plus angle COR plus angle ROD plus angle SOD. Sum of all these angles is how much? 360 degrees, right? But now what do we have? We have angle SOA equal to AOP. So AOP and SOA, where is that? Or AOS? So AOP and I forgot to write that angle. Plus angle SOA equal to 360 degree. I forgot to write this angle here. So now we have SOA, or OA, where is that? SOA equal to POA. So I can write this as 2 times, instead of AOP and SOA, I can write it as 2 times angle AOP or POA. So I can write this angle as 2 times of this, right? The entire angle I can write it as 2 times of AOP. Similarly, we have POB equal to QOB, which means POB and BOQ, right? These two are also, QOB and POB are equal. So I can write this as 2 times POB plus, now we have this angle and this angle equal, right? Okay, I'll erase all this now. I'll erase all this and just write O. Now we have this angle equal to this angle, which means I can, that is QOC and COR. So I can write this as 2 times COR plus, again this angle and this angle are equal, which means ROD and SOD are equal, which means I can write it as 2 times ROD equal to 360 degrees. Now 2 is common in all this, so I'll take 2 common. When I take 2 common, when I take 2 that side, it becomes 360 by 2, which is 180 degree. Now AOP plus POB, AOP plus POB is nothing but angle AOB, right? We get angle AOB. These two are equal to angle AOB plus COR plus ROD is equal to angle COD, equal to 180, 360 by 2, 180 degree. Hence this angle plus this angle is equal to 180 degree. Similarly, you can, like, instead of taking AOP and SOA as 2 times AOP, I could have taken it as 2 times SOA. So doing that way, you will also get this angle equal, this angle plus this angle equal to 180 degrees. So we have shown angles subtended by opposite sides of a quadrilateral at the center are supplementary. So we have proved that this angle plus this angle is 180 degrees.